Descartes' rule of signs. Is there a sign change?
No.
Is there a sign change?
No.
Is there a sign change? So there are no positive roots. Now,
No changes, but you can find changes.
no positive real roots, all right? So now now look, this is going to save you a lot of time. So we're going to put negative x cubed plus 6 negative x squared plus 5 times negative x plus 2. So when you cube a negative, it stays negative. When you square a negative, so no signs change.
Change that to a negative, and nothing happens finally.
So you've got 1,
Oh, yep.
2,
Yep.
so we have 3 or 1 negative real root. Okay, so now we're going to say, what is P? 2. What is Q? 2. So you're going to have plus or minus 1, plus or minus 2, all over 1 and 2. So what does this produce? This produces plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1, and what's 2 over 2? 1. So what can we be guaranteed of right now? There are no positive real roots. So are you going to use positive 1, 1/2, or 2? No, you are not. So we've got 2, 6, 5, 2. What are we going to use first? Negative 2. So we are going to bring down 2. What's negative 2 times 2? Add, you get 2. It's negative 2 times 2. Add, negative 2, we get 0. So x equals negative 2 is one of our roots. From here, we're going to write this as 2x squared plus 2x plus 1 equals 0. Are there any combination of factors that are going to give me 2 in the middle if I have to add? So we're going to do the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Or negative 2 plus or minus the square root of 4, that looks like minus 8. Agreed?
Agreed.
Remember I said you might have to use quadratic formula yesterday? What's square root of negative 4? Negative 2 plus or minus 2i over 4. Can we factor? So if I factor out a 2, then I'm going to have 1 plus or minus I over 4, which is going to be, so we have x equals negative 2, we have x equals 1 plus I over 2, and we have x equals positive 1 minus I over 2. Those are your 3 solutions. Let me start this up again so we know that there was a correction, that I forgot that was a negative, so that's what we have. Now, these aren't considered negative and positive because they're not real. So in this case, remember how we said we had 3 or 1? Guess what we had? 1 negative real root. Any other questions on this? No? Okay. So I think that's going to, I think that's going to end. Okay, wait a minute. I've got to teach today. Here we go. So now we're going to start. Here we go. Almost forgot. This is section 3.5. Start taking notes. We're learning. We're learning. All right. So it's all about rational functions right now. We're going to find the domain of a rational function. We're going to determine the end behavior of rational functions. We're going to and I think today it's the vertical asymptotes of a rational function. So, here we go. Now, this is going way back to the beginning. Way back to the beginning on domain. Domain of a function are the real numbers for which the x values of the functions are defined. Remember, parentheses means the endpoint is not included. Brackets means the endpoint is included. Do you remember that? Okay. We're going to use interval notation. And you have found the domain of rational functions in the past. I just don't think you knew what was happening at those numbers. So now we're building on what we already know. Okay, remember, rational functions in the form of polynomial over polynomial. What's wrong here?
Can't have a 0.
You can't divide by 0. What is 0 over 5? 0. This, when 5 is in the denominator, that's called undefined.
Can't find that in the dictionary.
Okay, do you remember this? Okay. So to find the domain of a rational function, okay. So you're going to factor the numerator and denominator. You're going to set the denominator equal to 0 and solve. I don't know why I said factor the numerator unless I want you to find holes too. The x values that you found in step 2 from the denominator must be excluded from the domain because they make the denominator equal to 0. So in the interval notation, you must use parentheses. But you already know this. So let me see what if there's anything new. All right, so I think they still, I'm not seeing why you need to do the numerator here because we're not going for holes, I don't believe. I think we're just going for asymptotes. So if we do our first problem, it's all about the denominator cannot be 0. How does this denominator factor?
X minus something, you know, x minus 4, x minus 2.
Okay, I heard minus 4. Minus 3?
Yep.
Or plus 3?
Minus.
Oh, it has to be minus. Why does it have to be minus?
Plus up there, so you know it's double negative.
God, someone taught you well. So that means x equals 4, x equals 3. Let's go through it. What's the multiplicity here? 1. All right. So what's happening? These are vertical asymptotes. Because it makes the denominator 0. So your domain would be negative infinity to 3, union 3 to 4, union 4 to infinity. Do you remember doing this?
A little bit.
We did this on domain earlier.
I didn't like it, but we did it.
Well, it's back, so maybe you'll get over that dislike. So we're going to factor this, set it equal to 0. What are the factors of 36 that subtract to give me 9?
All right. Are you all right there? Need some water?
All right, so we get x equals 12 and we get x equals negative 3. So let's see. Amy, can you give me this domain? Good. Okay, so this negative 3 to 12 and, all right, so let me show you something you can do to make sure that you get all 3 pieces. If you draw a number line and you put in the numbers, you know you're going to go from negative infinity up to negative 3 up to 12, and then 12 to infinity. That little picture will help.
What would you put back?
Because brackets include it, and if we include it, then we're including 0 in the denominator.
Where are we going to put back?
Not when we have 0 in the denominator, no. All right. We've got a lot of studying to do for this next test.
Next one is this one.
The one coming up, Wednesday's test. You got a lot of studying to do.
You gave us a lot of.
I did.
All right.
But you need to do it.
I
Okay.
for you, Mr. Bryan.
Thank you. All right, now we're going to determine the end behavior of a rational function. Again, describing behavior of functions at asymptotes, all right? So as x approaches, okay, so this is not just end behavior, this is just behavior. So we're describing end behavior. If you need more, there's more. We are determining end behavior and behavior at asymptotes. And it looks like everything here is going to be now this right here is end behavior that will be on this test. So let's do end behavior first. So as x goes to the left forever, what are the y values approach? What? X goes to negative infinity, what are the y values doing? What? No, they're not, because what's going to happen? As x goes to negative infinity, what's going to keep those y values from going up forever?
Oh,
Right, so what is y approaching? 1. As x goes to the right forever, what are the y values approaching? 1. Here they're approaching 1 from the bottom, here they're approaching 1 from the top. So that's end behavior that's on the next test. Now this is asymptotic behavior. Just this part.
Can we change that word?
Asymptotic?
Yeah, I don't
No. All right, now look at this funny thing that they did here. They put a negative sign after the 2. And they put a positive sign after the 2. Look at that. Is that bizarre?
Is that because
Okay. This means when you have 2 with the negative sign, this means left of 2. When you see 2 with the plus, that means right of 2. So as x approaches negative 2 from the left, do you see this is negative 2? Yes? Okay. This is left, and this is what? Right. So as the, now, is a function up here on the left side? Up here. Or is it down here? So as x goes to negative 2 from the left, what are these y values doing? Going down forever. Negative infinity. Now, here's the right side. Hop on the function, get closer and closer and closer. What are the y values doing? Going up forever, positive infinity. So now we're going to approach 4 from the what? Right. So here's 1, 2, 3. Here's 4. This is left. This is right. So here's the function. As I approach from the right, what are the y values doing? They're going up forever. However, on the left side of 4, what are they doing? They're going down forever. Right. This is approaching the asymptote from the right. This is approaching the asymptote from the left.
She's going like the line is going towards 4.
You're going towards 4.
Okay.
But you can go towards 4 this way, or you can go towards 4 this way. That's the right side, that's the left side. So find the function, and you don't want to go this way because you're not getting closer to 4. You're going away from 4. This is getting closer to 4. Does that make sense? And the y values are going up. Let's do more. Okay, so as x approaches negative 3 from the left, what are the y values approaching? Here's negative 3. They are going down forever, right? Okay, as x approaches negative 3 from the right side, here's negative 3. What are the y values doing? The y values are going up forever. So now as x, what's the next vertical? Positive 3. As we approach positive 3 from the left side of 3, what are the y values doing? The y values are approaching positive infinity. As x approaches 3 from the right now, what are the y values doing?
They're going in a downward motion.
They're going down forever. Now, let's do as x approaches positive infinity. This is what the infinities is what's on your test. So this is positive infinity. So as x goes this way forever, what are the y values approaching? -1. As x approaches negative infinity, what is f of x approaching? Here's negative infinity. As x's go this way forever, what are the y's getting closer to? -1. Is it always going to be -1? In this, well, is it approaching -1 both ways? Yes. But a piecewise function, that can mess it all up.
No, those aren't.
It could.
Are they?
All right.
Are they going to hand us the graph? Are they going to give us the graph, or we have to make the graph?
Who's they? The book?
Yeah, the book.
On the vertical asymptotes. Yes. Vertical asymptotes occur when the denominator is equal to 0. So to find them, you factor the denominator, set the denominator equal to 0. So if I want to find the vertical asymptotes, we do it just like we would do domain. 2x squared minus 9x minus 5 equals 0. How does this factor? I'll do 2x and 1x. Then what? Minus, plus, because that gives me -10 plus 1 is -9. So we'll say 2x plus 1 equals 0. 2x equals -1, x equals -1. Here we've got x minus 5 equals 0, x equals what? So where are the vertical asymptotes? X equal 1/2 and x equals 5. They are vertical lines. You must have x equals, or I don't give you credit, because then you don't have the concept. Is that hard?
No.
Are you going to like these better than what we've been doing?
Yeah, so far.
Okay, how do we get vertical asymptotes? Is it about the numerator?
No.
No.
Get that out of here.
8x squared minus 2x minus 3 equals 0. What are we going to do?
Back to that.
I'm thinking 4x, 2x.
All right. I don't know what you think.
But now what are we going to do? I need 2 in the middle.
-3.
So that gives me -6, positive 4, which gives me -2. X equals 3/4 and x equals what? -1/2. What did we just find? The vertical asymptotes.
You're a great teacher.
Is that easy? How do we get these vertical asymptotes?
X minus 1, X plus 1.
X minus 1, x plus 1, set that equal to 0. What do we get?
X equal -1 and X 1.
So, don't you do this when you do domain? And then you have to go to interval notation? So if you stop at this level of domain, you have your vertical asymptotes.
All right, so we're stopping.
We're stopping.
That's all.
That's all for today, folks.
Just smiley face.
Okay, but it really isn't all for today.
No.
Because now what you are going to do, let's look at our test objectives. I will give you a quadratic in. I am not giving it to you in vertex form. I'm giving it to you what? Standard form. You will find the coordinates of the vertex, how it opens, tell whether it's a maximum or minimum, give domain, give range, write the equation of the axis of symmetry, and graph on graph paper. That is one question on your test. One question. Now, second question. I will give you a polynomial in factored form, and you will find the zeros and give the multiplicity of each. Have I asked you to graph at this point? No. So it'll be already factored. Give me the zeros and multiplicity. Okay, now how many are you going to have? 2. Given a polynomial in factored form and non-factored form. So can you guess why there's 2 of them? Can you guess why there's 2? 1 in factored and 1 non-factored. You will write the end behavior. You will find the x-intercepts and determine whether it crosses or turns. You will find the y-intercept and you will graph. So how many graphs do you have?
None.
How many graphs? 1, 2, 3. You have one long division.
Why do we just make half % long?
You have one remainder theorem. What's the remainder theorem?
What we just did.
What's the remainder theorem?
Find it.
This should be the easiest question on the test. I don't want you to blow it. How do you do it? No, it's not remainder theorem. You substitute the 0 into x. Plug and chug. All right, I will give you one Descartes' rule of signs to determine the positive and negative roots. Just one. Now, do you know your homework last night? Remember your homework last night? Did I give you any hint as to what a 0 was? No. But look, I'm going to ask you to find all zeros, and I will give you the first. So will you be ready for synthetic division? Yes. I will ask you just to list all possible rational roots. Just list. Nothing else. Now, I will ask you to find all the zeros of a polynomial that cannot be factored using factor by grouping. This is last night's homework that took all that time. And then last but not least, you will write a polynomial given its roots. So I will post these on the website. And I'll go over 833 tomorrow, and then we're going to start doing this. I've got a study guide on this when I post this. Any questions?
So if you want to take this negative x squared and the plus 4x and the minus 1, would that equal a homework pass?
How would that equal homework pass?
See what I did there? Pass.
No, I'm confused.
I made it into